He has completed his PhD in engineering with 23 years of rich cross-functional experience. He is a member of professional bodies like IEEE, ACM, IIT, and many more. He has 120 plus research and publication. He has reviewed 3,200 plus articles, 4 international expert talk, 25 plus national talk, and many more other achievements. It's not possible to mention all of them in short duration. We are very lucky to have such a wonderful personality for our today's session. I welcome you, sir. I hand over this session to you. Over to you now. Welcome you again.
Thank you, ma'am. Thank you so much. Let me share the screen. Is it visible and audible?
Yes, sir.
So thank you, everyone. Good afternoon, everyone. So with your permission, can I proceed further?
Sure, sir.
Okay. So today's talk will be on introduction on Industry Automation 4.0. So the outline of this talk will be like this. So first of all, we'll go through introduction, followed by benefits of Industry Automation 4.0 and what are the industrial revolutions so far, as well as what are the different challenges and issues, how to address that issues while implementing, deploying Industry Automation 4.0 in industry, corporate sector, day-to-day life. Then for subsequently, we'll like to go through applications of Industry Automation 4.0 as well as future of Industry Automation 4.0. And let me also, you all might be aware that we are on the verge of migrating from 4.0 to 5.0. So we'll have glimpses and some overview of Industry 5.0 also. The name of talk is, although it is Automation 4.0, but people started working way back on Industry 5.0 also. So we'd like to go through that also. So this is the outline and then outline of the presentation. So if you see, industry automation will start with what are the different definitions, how it started, and how we can relate, how we can connect society also. So industry and society, this is as far as whatever industries are there, technologies are there, and professions are there, we need to connect it to society. Because after all, with the help of technological advancement, we are supposed to connect our life to get advanced, get living standard better, so that we can achieve more and more, and everybody in the society will get benefits. So in introduction, we'll try to see through like definition of Industry Automation 4.0, history, evolution, and other factors, key features of Industry 4.0. So let us go through the definition and historical perspective of the Industry 4.0. So as you aware that there are, if you go through the text, or we can say literature also, there are many more definitions are there, author to author, it definitions are changing, but more or less all the definitions are sounding similar. So the general definition of Industry 4.0 is nothing but it is the rise of digital industrial technology. Okay, so as per Daniel Burrus, who is one of the pioneers in this sector, so he is saying that Industry 4.0 transformation allows to work alongside machines in new and highly productive ways. So whenever we see, whenever we are proposing any technology, any solution, any project, any idea, or anything, that must have concrete productive outcome. That should be efficient. That should be optimal. That should be also cost efficient, economical. So what we are trying to see here, machines, we are going to work with machines, and that too also with new concepts to give new highly productive ways. So this is one of the definition which is coined by Daniel Burrus. And the first phrase, the first term forced in fourth industrial revolution was first coined by a team of scientists from Germany, and which was headed by Klaus Schwab, who was the executive chairman of World Economic Forum. So Shaw was the person who introduced this phrase in 2015 in the Foreign Affairs magazine of which was published in 2015. And the theme for this was mastering the fourth industrial revolution. So far, we started with first industrial revolution, second industrial revolution, and so on. So based on that, there was brainstorming in that particular session, a meeting, and which took place in Davos cluster, Switzerland. And it was under the World Economic Forum's annual meeting. So he is the person who first coined the term Industry 4.0. So let us move to the next slide. So when we are discussing technology, so we must also discuss what is the vision, what is the mission of this technology. So if we see, we are day by day, we are going on miniaturization culture, we are going on advancement in techniques. So how it affects our society or individual and community life also. So if you see how we can connect this industry also has gone through industrial revolution 1, 2, 3, 4, 5, and even society is way back started, and it has also got improvement in living style and all that with all the sophisticated gadgets and electronic gadgets and um, internet and other technologies. So we need to connect how we can improve our day-to-day life and living life, or life on planet. So from that perspective, this slide need to be discussed. So at one side we have industry, other side we have society. So if you see, industry promote talents, diversity and empowerment, where society ensures high quality lives full of comfort and vitality. So as somebody said, inventions are necessity is mother of inventions. Like that, we day to day we never stop. If you see, even in cellular technologies, we are working on 6G. Now people also started working on 7G. So everywhere you can see, day to day human being wants to improve their life, our life, society's life, so that we will get more comfort, more leisure. So we cannot neglect the industry is different and society is different. What I will say, rather I will say, we should connect whatever technology we are using, whatever gadgets, softwares, or anything we are using, mechanisms we are using, that should be useful for the humankind, that should be useful for the last person of the society, that should be useful for the undertrodden people, underprivileged people. So if you see, industry promotes talents, diversity and empowerment, wherein society also ensures at same time high quality living full of comfort and vitality. If you see other side, society provides necessary goods and services for industry people and necessary level when needed. Okay. So if you say industry is having resilient approach, it is agile, resilient with flexible and adaptable technologies. If you say other side, society is merged between cyberspace and physical space, 5G or 6G, big data, AI, like emerging technologies, where your industry leads action on sustainability and respects planetary boundaries. So we cannot neglect societal life, individual life, community life, life on planet, life by reason. So that also need to be seen how industry 4.0 or 4.0 or industry 5.0 adding value to your life, adding new dimensions to your life. So for that, this slide is there just for creating ambience. If you see society transformations and industry evolution. So as we are discussing industry 4.0 and 5.0, so we need to discuss also society's improvement in the human life, improvement or human life's transition from hunter-gatherer society. If you see way back, it was society 1.0, 1.0, society 2.0 was agricultural revolution, then it was industrial society, then information society. And if you see, it is a combination of this. So if you see at other side, you have you start from hunter gatherer society, which is to earn bread and butter and all that, and then it is slowly graduated, migrated to agricultural society, then industrial aspects come, then information technology came, and now super now it is on, now it is presently it is super smart society. If you see other side, industry 1.0, it started with machines, then hydraulics, pneumatics, then drives and controls and mechatronics, and slowly we are coming to the intelligent systems. So this way we can connect and we can connect and relate the industry and society transformation, because these should go hand in hand. It should not like the industrial revolution is going in a other direction and society is going in other direction. That also need to think. And industry, if we see industry 5.0, it is bringing more human touch. Okay, then we'll see the transformations or dimensions. So if we compare the frameworks of industry 5.0 and society 5.0, so there are various dimensions. So it has at other side you can see research and development is there, manufacturing is there, AI is there, IoT is there, then augmented reality, virtual reality, all these things are there. So it has four dimensions: goal dimensions, technology dimensions, society 5.0 is another dimension, industry. So this picture is self-explanatory. We cannot neglect society and industry. These are the different domains, because what is the motive of industrial revolution or technological revolution or technological advancement? To improve the human life, to improve the living standards of the society, and that is it is the medium. Technology is the medium through which we are supposed to improve the life, and these are the some of the dimensions which need to be uh, brainstormed while we are coming up with new technologies. Then, if you see this, there are some of the summary of challenges and opportunities. This is summary of only industry and society perspective, not summary and of industry 4.0 or 5.0. So if you see challenges are what, if you want to go hand in hand with industry and society or transformation, if you want to club it together, these are the some of the challenges. First is aging populations. Okay, then the shortage of resources, and environmental pollution is there, and day by day it is increasing. Resources shortcomings are there, and complex international situations are there. So these are the some of the challenges for industry and society transformation should go hand in hand. Then what are the opportunities? So these are the areas where we have ample opportunities: human cyber physical systems, green intelligent manufacturing, means green communications, green networks, green fuels, everything green, go green like concept. Then human robot collaboration, and future jobs and future workers, and human digital twin. So this is virtual. So these are some of the opportunities and these are some of the challenges. But what we need to do, we need to convert our challenges into opportunities with the help of technological advancement as well as value system. So this was just how to relate our human life with society. So if we see industry 4.0, it came from, if you see first industrial revolution, it was started from steam. Now we are reached to the sensors. So this is the historical context for industry 4.0. Okay, if you see so far we have five types of industrial revolution. First industrial revolution, it started with steam, then second and third and fourth and fifth. So now we have sensors, and sensors are like, it is without sensors, every system is handicapped nowadays. So we started with steam and now we are at the verge of using sensors, rather I will say intelligent sensors, not smart sensors also. That's intelligent and smart sensors I will come to in upcoming slides. So these are the some of the revolutions. Now this is pictorial format, how we can relate first industrial revolution and fifth one. So if you see first industrial revolution, if you want to relate with some analogy, so that is water and steam power was generated. So if you see, this is railway engine and all that. So this was the first industrial revolution. Second, if you see mass production of assembly lines. Okay, this was your this was second industrial revolution. And if you see third industrial revolution is having automation, mean hydraulics, pneumatics, which is which is the branches which work on the fluid power. And then subsequently PLCs came, then SCADA came, then mechatronics, robotics, and mechatronics. So these are the some of the things which is nothing but the third industrial revolution. And in fourth industrial revolutions, you have cyber physical systems, sensors and all that, computers and all that. And fifth, we can say it is intelligent systems. Okay, I will come to the point. I will also describe what is the difference between smart and intelligent also. So this is just for understanding how you can pictorially understand and relate the industrial revolutions. So if you want to just say to a layman person, water and steam engine was like a first industrial revolution. and assembly lines and plants are second. Then when the with the advent of hydraulics, pneumatics, relays and solenoid, this was third, and then sensors and all that, that was mechatronics, that is the fourth. And now we are on the verge of migrating to the 5.0 or in the fifth industrial revolution. So this was industrial revolution. So some of the pictures are used from Pixabay. Now, if you see, this is one more slide which will clearly explain the industrial revolutions. So when we say industry 1.0, it is mechanization of water and steam powers. It was totally based on power engineering. Then when we subsequently migrate to industry 2.0, it is mass production electrical power assembly lines. I already told you, and it was started way back in 1900. Then when we are coming to the industry 3.0, it is nothing but the computers, computer systems, automated production, electronics, hydraulics, pneumatics, PLCs, signal conditioning, then we can say relays, solenoid valves, and all that. Then when we say industry 4.0, it is cyber physical systems, internet of things, networking, machine learning. Okay. And in industry 5.0 is much more advanced. It is nothing but the human machine interaction, human machine collaboration, cobots and all that, cognitive systems, and it is more customized, and it is they are trying to bring the human touch. So human being is at the center. Okay, so this way, this is one more slide how it explains industrial revolution so far. Then, if you see the fact history of industrial revolutions, means if you refer different literatures, you will get more or less some different information. But we can say again, it is he is saying that it started in 1780, that is mechanization. 1870 started second revolution, it is the more or less electrification came into picture. In 1970 automation has been coined, and in 1980 globalization, and today we are in the world of digitalization, where we have introduced connected devices and data analytics and AI. And in future, the industrial revolution of the industry 5.0 will be focused on cooperation, collaboration between machines and cobots, and man and cobots, or there will be more communication between human machine, and there will be less whatever complex or uh, tedious, cumbersome ideas are there or jobs are there, they will be replaced by cobots, and most of the difficult and cumbersome, time consuming and energy draining will be uh, shared by, or they will be shared, what we can say, they will be taken up by the cobots. I hope I am audible and visible. Moving to the again one of the slide which is describing potential opportunities and adoption of challenge. So if you see, again, this is one way to introduce how our revolution started. So steam engine and mass production by machine, we can say that is in the industrial revolution 1, and assembly lines, that is again industrial revolution 2. Automations, IT systems and all that, that is industry revolution 3, we can say. Digitization of everything, IoTs and all that, that is we can say industry 4.0. Even we can say that is the smart systems, and industry 5.0 we can say it is the intelligent systems. So let me define, there is this intelligent means what? The systems or machines or whatever phenomena is that that are replicating human actions. They are having capabilities like human being. They can mimic, they can imitate the actions, they can take decisions, they can think. So that kind of things you can say intelligent systems or intelligent sensors also. Okay, so whenever we are defining any machine, system, sensor, or anything, any phenomena, if you say smart, it does not have that thinking capability. It does not have that decision-making capability. Okay, and when you are saying intelligent, it can take decisions like human being. It can mimic. It can imitate the actions. So that is the difference between smart systems and intelligent systems. So we can see industry 4.0 is more or less smart systems or smart technologies, and industry 5.0 or future industrial revolutions will be more like, we can say, intelligent systems. They will predict the maintenance, they will announce, they will declare the maintenance, or they can take decisions in some of the cases, in failure cases or anything. Okay, so this way we can discriminate between smart systems and intelligence system. So if you see industry 5.0 means it will be using cyber physical systems based on cognitive systems. Green manufacturing or green concept will be more popularized so that we can preserve our planet Earth, Mother Nature, and we can prevent or preserve our ecosystems. Cultural collaboration will be there, human being and personal touch will be there, human being will be at the center, and mass customization. You will be having personalized devices, customized devices as per your need. So that is the focus of industry 5.0. Okay, so this was taken from one of the literature. Moving to the another thing, illustration of industrial revolution. This is pyramidal approach, we can say, which started with 1.4, and in that mechanical production was at the center, water and steam power. Slowly it migrated to electrical, then you can say electronic and IT system, I can say mechatronic systems, and now automation technologies or modern automation technology. Means what we can say, it started with mechanical engineering and then combination of electromechanical systems, then mechatronics, and now it is intelligent systems or automation intelligent automation systems, we can say. Okay, if you see here, division of labor and electrical energy came into picture in industry 2.0. Then with the help of electronics, IT systems and computerized mechanisms, industry 3.0 way back started in 1969, and 2011 it started with industry 4.0, and now we are slowly and gradually moving towards the industry 5.0, where mass personalization will be there. Their devices will be more personalized, plants or the systems will be more personalized and more customized. So this was one thing. Then there is another picture which tells us about these industrial revolutions. You can say these are some of the areas, or these are the technologies we can say which are used in industry 4.0. Smart buildings, smart mobility, smart grid for managing the energy, smart logistic for managing the transportations, a business web, social web, smart homes. So this is one of the way how we can represent or understand the industry 4.0. Okay, so let us move to the next. So what we can say, industry 4.0 is nothing but it has come a long way since the first industrial revolution, and with the advent of industry 4.0, we are seeing a new era of automation and mechatronics that is driven by data and connectivity. Now if you see, industry 4.0 and industry 5.0, they are mainly dependent on data. You name the technology today, let it be cyber security, IoT, AI, machine learning, data analytics, big data, edge computing, everywhere data is essential. Data is new oil, means people are saying data is new oil, data is new gold, data is very precious. Without data you cannot do anything. Now data is at the center point. If you can understand data, or if you can wisely collect the data, okay, and if you can categorize it, catalog it properly, you can represent it properly, and if you can make the analysis of data, okay, because if you do the data analysis, okay, then you can get some insights from it, and that insights will help you to improve your system, improve your reliability, improve your efficiency, improve your what other outcomes. So everywhere if you see, we are always doing analysis, and from analysis we are getting synthesized data. We can make some interpretations, we can make some conclusions, and based on that conclusions, comments or findings and discussions, we may get new insights, and that new insights will help you to take further decisions, so that whatever system you are using, whatever phenomena or whatever conditions you are, you can improve it in the next turn. So that is the best part of data. If I'm not, if I would like to say rather, data is nothing but information. Okay, and information is nothing but what? Information. Your information may be audio, may be video, may be music, may be codes, symbols, characters, numeric documents, Excel sheets, anything. That is information. And if you now you can say electronic people say that is signal. Okay, and computers and other allied branches say that is data. So if you convert that signal, into electrical and subsequently into series of zeros and ones, it becomes data. So first of all, what you are supposed to do, you need to understand data, or for that you need to understand the business problem. And then when you know that particular problem, then you can collect data wisely. Data collection is also an art. And then grouping it, clustering it, cataloging it, customizing it, it is another, because every when you are grouping, that will give some reflective features, and from that you will get some insights. So data is very important. Without data and sensors, if you see at one side you have data and other side you have sensors, or sensors actuators, I will say rather. So that are very important and essential part of your any system, any technology. So here, if you understand data very well, if you have that capabilities to explore that data, interpret it, analyze it, visualize it, explore it, then you can do wonders. Because without data and sensors and connectivity, the system will be handicapped. So here, all systems, all the mechanisms are driven by data and connectivity. One cannot neglect connectivity and data. Without data and connectivity, no one can do anything. So we are simply handicapped. Any technology will remain handicapped. So this industry 4.0 is characterized by what? Data and connectivity. These are the one of the important aspects, and it is nothing but integration or clubbing or augmentation of physical systems with digital technologies, and that creates a smart factory. Rather, I will say we are on the verge of migrating slowly and gradually to intelligent systems or intelligent factories. I already told you what is the difference between the smart and intelligent. Okay, so it is nothing but integration or augmentation of digital technologies or sophisticated technologies or sensors and all that, actuators, along with physical systems, and the key technologies that make decision capabilities. So this industry 4.0 system, it is also doing optimization. Optimization is separate area where I can deliver 1 hour lecture, because you have to use your resources to optimally, so that your efficiency will improve, everything will improve. So it is a very beautiful concept, like you can say it is physical systems with digital technologies as well as optimization, and we are also introducing here decision making capability. Okay, like we human being can take decisions. So, and if you want to introduce this factor, industry 4.0, so you need to depend upon the technologies like IoT, or rather I will say industrial IoT, artificial intelligence, machine learning, robotics, big data analytics. And these technologies, if you club together, they can create a connected ecosystem which is very efficient and can communicate with each other. Again, I am saying here, analyze data in real time and make decisions based on data. So we cannot deny the importance or presence of data. Data is like backbone of your system. Okay, and if you say those who are very well, those who are aware about AI, there is like agent. Agent is nothing but it is sensor actuator system, and in computers, agent is nothing but it is computer architecture and programming. Okay, so these agents are very important, and these intelligent agents are also there. Like I said, smart agents. So there can be dumb agent, smart agent, traditional agent, and intelligent agent. So intelligent agent system is nothing but it is a sensor actuator system, which is useful, which is used to sense some physical parameters, as well as it will given means it will be sensed by sensors. That sensors can be smart sensors or intelligent sensors, and through your controllers or some systems, the action or decision is given to the actuators. So it is like it is like Jodi sensor actuator. So agents are also important. Okay. So this is the idea about what is in what this is the introduction of Industry 4.0. I hope you might have got some a few things from this slide. So let us come to the smart factory. So Industry 4.0 is nothing but it is when we are discussing more about manufacturing. We'll come to other domains also. So what do you mean by smart factory? Way back in Industrial Revolution 1, 2, 3, we had factories, we had plants. So if we say smart factory will have memories, will have controllers, will have signal conditioning equipments, circuits. It will have sensors, it will have actuators, control systems, transmitters, receivers, and all that. Okay. So, but I already told you about intelligent systems. So let us discuss what is smart factory. So it is often called as a digital factory. Okay. So, or we can say rather it is intelligent factory or smart manufacturing. Okay. And these names describe modern technology used in facilities. And with the help of smart factories, what we are doing, you are generating hyper flexible, self-adapting production in which automation, additive manufacturing, IoT, robotics, data analysis, and cloud systems are used. Okay, so when we say manufacturing, you may have mechanical systems or electromechanical systems, electronic systems. You may have control systems also. You have IoT, which is based on internet. You have robotics. You may have combination of hydraulics, pneumatics, or complete mechatronic setup. Then you have to use data analyst or data analytics, we can say, because data will be coming from different resources. If that data is not organized, you have to organize that data. If it is unstructured, you have to structure it. If it is not in proper format, you have to bring it in proper format. You have to then categorize it. You have to catalog it. You have to you have to make analysis, synthesis, interpretation, and if required, you can explore it and do visualizations. And as far as robotics is concerned, it will have sensors again, actuators again, drivers will be there. Drivers are very important. Then for storage capacity, you need cloud systems. Okay, so this is we can say it is one of the example of mechatronics. You can say, means earlier what was there, mechanical branch was different, and mechanical, electrical, all this manufacturing, whatever we can say process was there, that was sequential. First you have to procure the raw material, then you have to do some job, then finishing, quality control, and all that. So in between, if you stuck somewhere, so your production will stop or your final product will not come. But when we say mechatronics approach or modern manufacturing approach, it is concurrent approach, it is simultaneous approach. So there will be team of computer engineers, there will be team of electronic engineers which will look after signal conditioning sensors, and there will be team of control system, there will be team for metallurgical engineers or production engineers, they will look after raw material and job doing and all that machining thing. Then there will be team of quality engineers and all that. So this is concurrent approach. That's the reason mechatronics and automation technologies are famous, because they are able to meet the deadlines. Okay, and with the help of this IoT, AI, and other technologies like blockchain, you are improving your efficiency. So this was all about smart factory. Let us move to the next slide. Rise of smart factory. So if you see, Industry 4.0 is revolutionizing the way companies operate, integrating functioning new technologies like IoT, cloud computing, and AI in production facilities. Okay, this also leads to increased automation, predictive maintenance, self-optimization, and improved efficiency and responsiveness. Means now machines will declare, now system will declare, or some part will declare where it is going to fail. Or if it is going to fail, it will be, the load will be migrated to other systems. If one sensor is on the verge of, let us say it fails, then within a fraction of second, that sensor's load or that functionality will be diverted to other. Okay, so this way you can migrate the load, or you can replace, or they will declare the maintenance. Means that way they will become intelligent systems. Okay, so this, due to this, what will happen, system becomes optimized, improved efficiency and responsiveness. Then smart sensors is again, it is like a heart of, or you can say brain of, what we can say, industry 4.0 process, or we can say techno revolution. So without sensors, one cannot deny one cannot deny the importance of sensors. Without sensors, we are handicapped. You name the physical quantity in the world or physical properties, let it be metals properties, any physical quantity in the world, pressure, fluid, anything, chemical flow, humidity, moisture, anything. Let it be our physiological parameters like blood pressure, blood protein, everywhere. Or even our physiological anatomical properties, there are sensors and they are called as biomarkers and sensors. Okay, so for everything, the sensor is available nowadays, and that too intelligent sensors. There are various types of sensors, analog sensors, digital sensors, even quasi sensors are there. And it is not limited. One sensor can capture or can sense 5 to 6 um, parameters or properties. So now there now and we are latest sensors are intelligent sensors, non-smart sensors. So sensors are backbone of any revolution. You name the domain, whether it is autonomous systems, automobiles, electric vehicles, anything, manufacturing, everywhere. Even in our appliances, everywhere sensors are there. Earlier, manual systems were there, electrophysical systems were there. Now, totally depend on sensors. But sensor is a, let me tell you, when sensor fails, you can have the then whether you have to use one single sensor or array of sensors, that also matters. Its size and everything. So that is another domain where people can work. Sensors is a hot area nowadays because very few people are working in sensor designing and all that. Even there are nano sensors and MEMS, micro electromechanical sensors are there, nano electromechanical sensors are there, cantilever sensors are there. So that is one of the area where lot many opportunities are there. And you name the new technology without sensors, even AI, there are agents. Means uh, sensor actuator system in electronics and electricals is known as computer architecture and programming. That is agent in AI. So one cannot imagine life without sensors or industry without sensors. Now, let us come to the next slide, which are, let us see what are the technologies which are driving industry 4.0. First is Internet of Things. Rather, it is, there are many versions of it. Internet of everything, Internet of this, Internet of vehicles and all that. And rather in industry, it is in industries, Internet of industrial things. Then cloud computing is there. Cloud computing is mainly used for data storage and data handling. Then AI and machine learning, everywhere it is used. And with the advent of AI and machine learning, people are getting more fruitful outcomes, more efficiency, more reliable results, more accurate and precise results. Then edge computing is there. Cyber security is there for security, privacy, and all that. That is also main concern, because nowadays it is very crucial to preserve your data, preserve your privacy. Digital twin is virtual environment where you can actually simulate it in simulation way you can see. Then autonomous robots, they are uh, they are used in many applications where complex systems are there in industries, in refineries, in biomedical also robots are used. Then there are various types of robots are used. Robots are coming up. Big data is another thing. because now we are supposed to handle massive data. So data visualization, data analytics, and data exploration are the fields. Uh, they are having a they are in hype, and AI analytics. Then additive manufacturing and 3D printing, the rapid prototyping, they are coming up fields. These are the technologies, and you can say augmented reality, virtual reality. These are the technologies which are widely used in Industry 4.0. Let us move to the next. Now, if you see opportunities for Industry 4.0, so first opportunity is what developing smart factories provides an incredible opportunity for the manufacturing industry. Okay, so I already told you about smart factories. Smart factories will have setup like data collection, sensors, arrow sensors, signal conditioning equipments, then controllers, actuators, then connectivity. For connectivity you need networks, then transmitters, receivers, then cloud will be required, as well as IoT is required. So this is if you are using these technologies, then you are slowly and gradually moving to the industry. These are the core segments. Then analyzing the large amounts of big data collected from sensors on the factory floor ensures real-time visibility. Means you can supervise, monitor, and regularize. See, why we want to monitor? Let us consider any plant. So that plant may have thousands of parameters: uh, boiler pressure, fluid flow, chemical flow, humidity, temperature, manufacturing. How many products are manufactured? So you need to at least monitor 100 to 1,000 parameters. You may need 100 for monitoring 1,000 parameters. You may need 1,000 sensors also. But these days, one sensor can monitor 5 to 6 parameters. So you may need 100 to 200 sensors. So you may need array of sensors. Then you may need multiplexing for that. So that sensors may be like a combination of analog sensors, digital sensors, quasi digital sensors, or they may have different types of outputs. You have to combine all them. You may have to use multiplexers. You may have to use decoders. You may have to use encoders. And if required for data privacy, you may have to use encryption and decryption also. You need to use wired or wireless channels. You may need transceivers. So all these are used because to improve the efficiency. So if you are monitoring all these 1,000 parameters, so you need to get you need to sense them, you need to monitor them, you need to observe them in real time. And if anything is not going as per our desirable, our action, so that can be corrected. So that's the reason we are always monitoring. That can be regulated, that can be corrected, that can be immediate action can be taken if anything fails or any production line fails. So you may need that kind of setup. So this ensures you real-time visibility of your manufacturing assets and can provide tools for performing predictive maintenance also. If something goes wrong, if some product, some module is not working, so that you can minimize the downtime. Okay. So earlier we need everywhere you need to deploy one person. Now with the advent of sensors, for everything there is sensors. There are some IR sensors, there are variety of sensors. So by usage of sensors, data conditioning, signal conditioning, data collection, controllers, actuators, and these technologies, you can simply convert your traditional factory into smart factories. Let us move to this. What are the benefits of industry automation 4.0? So if we are using industry 4.0, so it increases productivity and efficiency. Okay. So when you means when if you are monitoring your data or your parameters or processes in real time by deploying so many sensors, naturally you can correct your plant functionality in real time also, and it can be sorted out immediately. So that will improve your productivity as well as efficiency. It will save your energy, it will save your cost also. Then you get improved quality control, you can meet the deadlines, you can reduce the labor cost, and you can work efficiently, and you can have more production. You may get more benefits out of it. So when we come to in the benefits of industry automation, so these benefits are, there are numerous benefits, and they are far reaching. By creating a smart factory which is capable of self optimization. Self optimization means you have to use your resources to the fullest. When means none of the your resource should be remain idle, and that should be, if you use it optimally, naturally your reliability, efficiency, productivity will increase. And even in algorithms and in systems, we are always optimizing. In communication network also, people are optimizing communication networks. When we are writing algorithm, that also we are see to it that how it will take less time to complete the execution, how our program will take less time, it will consume less space in the memory or system. So here what we mean to say, if you want to optimize your resources, and that too on our own, so that is the best part of industry 4.0 or 5.0. Means systems and sensors and machines will take their own decisions, and they will manage themselves so that you will get optimized result. And also other the advantage is what? Autonomous, it has autonomous decision making capability. So with this two, optimization and autonomous decision making capability, businesses can achieve higher levels of efficiency, productivity, and profitability. And other thing of this is what? In addition, industry 4.0 enables businesses to better understand their operations. Means if you use data analysis or data analytics, or if you are applying it, means for using data analysis, you need to understand business problems or other problems or research problem. So you need to understand. If you are applying that, then you can take more decisions. Means you will collect data from different sources, you will analyze it, you will interpret it, and from that you will get some concrete results, and you will implement. That will help you in take the decisions, so that in next coming cycle you can improve the efficiency. So that is the beauty of data analysis and visualization. So by collecting huge and massive data in real time, businesses can identify bottlenecks where we are lagging, or what are the lacunas. They can optimize their processes, they can reduce their waste, and this leads in improving quality, also reduce cost and increase customer satisfaction. So these are the what some of the benefits of industry 4.0. Now, so that was pictorial this thing. So if you see what are the main benefits: intelligent products, then intelligent factories, intelligent assets, and empowered people. Okay, intelligent products means decision making capability, that too in complex situations. Okay, optimization with reduced cost, with more productivity. So that intelligent word is applicable here, means it has got that decision making capabilities, and that decision making capabilities are exactly with 1:1 correspondence to the human being. Means our machines will think like us, they are able to take decision like us, they can take decisions like us, they can declare their maintenance, they can declare when they are going to fail, they can announce ki after few days this part is going to non-functional. So same is applicable to factories. Already we have discussed smart factories. Intelligent factories are having, means it will have augmentation of AI and machine learning with data analytics, so that it can take decisions. Then intelligent assets and empowered people, means people people will be handling complex tasks with the help of robots and cobots. The manual intervention will be less, only manual guidance will be there. Okay, so these are the four aspects and benefits of industry 4.0. Now, how it will how it is helpful. So it is nothing but it is accelerated transition to the knowledge economy. We always speak about economy. So let me see, what is knowledge economy. Knowledge economy is an economic system in which production and services are largely based on knowledge intensive activities, and that contributes to an accelerated pace of technical and scientific advance, as well as rapid obsolescence. So this will help on knowledge economy. So this industry 4.0 technology aids or it believes in transition into knowledge economy by increasing reliance on intellectual capabilities. Like earlier, we don't have to sweat more. We don't have to spend more time on complex tasks. That crucial complex task will be handled by robots or cobots or other things. And that too exactly like our capabilities, what your human being is done. So we don't have to rely on manual intervention, or we don't have to spend more much time, even you don't have to use more muscle power. So this is the essence of it. So what he is saying, by increasing reliance on intellectual capabilities than on physical inputs or natural resources. So with the advent of Industry 4.0, we are moving to the knowledge economy. It helps. Then what kind of benefits companies are expecting from Industry 4.0? So companies, there are many companies, they have already started using it. So they are experiencing radical and revolutionary improvements in productivity and automation, because making data-driven decisions across their operations, they can forecast, they can predict. Okay, yeah, and all that they are useful for predicting, estimating. Okay, and with the help of that, they can get accuracy also, accurate prediction they are doing, and they are supporting on-time delivery. They can meet deadlines, and they can build more and more profit, and they can prepare a more profit optimized plans. So that kind of experiences are some of the companies are experiencing. Then they can get resiliency and agility. Okay, so what market or economy will bring? So companies are shaping the future digital supply chain based on the state of the art of planning. Means you can predict about supply and demand, and you can accordingly you can manage. Then companies are getting confidence to explore new businesses. They can be a launch or deploy new business models and seize opportunities quickly. So that is the third advantage. So because of Industry 4.0 solutions or ideas or proposals, businesses are reducing cost, improving market efficiency, okay, and connecting supply chains by sea, land, and air. Then fourth aspect is green and sustainable solutions. So without sacrificing profitability, that too without sacrificing profitability, customers are becoming more efficient and cost effective by going digital while meeting their environmental objectives, as well as without compromising on other business goals such as profitability and scalability. Means companies are experiencing this kind of things, corporate sector companies and factories. Now, if we want to move to the Industry 4.0, so what are the some of the steps? We are, let us say, we are traditional company, we are traditional plant. So how to enter it? What are the steps to be taken while entering to the Industry 4.0? So before you can determine a route, okay, so you need to know where to start. So first step is to audit and analyze the existing processes, assets, and business system. So haphazardly, you cannot say, okay, I can directly convert my plant, my process, my business, my corporate into Industry 4.0. You have to think a lot, because you need to know, you need to analyze it. You need to understand your business processes, business assets, your resources, your systems, your economical capabilities, and then you can enter. Because with this analysis, if you understand your business problem, then you need to collect relevant data related to it. Then you have to make that data categorization, cataloging, then data processing, data processing, data analyzing, data cleaning, data wrangling. Then you can, if required, you can do data analysis and interpretation. And further, you can also use data visualization and exploration also. So if you do all these types of analysis, because that set of mindset is also required. So this will tell you where you are, and that will help you to establish priorities and even identify quick wins. So Industry 4.0 solutions will result in a significant benefit and impact across every area of business. So if you do proper analytics and proper findings, you can easily implement it. So it is more than just an IT upgrade. It is not just to get all the technology, softwares, hardwares, and firmwares and convert it. But rather, it is, you should ensure that You have an executive buy-in and engagement. You should be able to engage your resources. You should be, no resource should remain idle. That is nothing but optimization. Your resources should be used to the fullest. So these are the some of the steps to get into Industry 4.0. Then how to connect older machinery to digital network. So if you say IoT gateway devices, like you can be retrofitted to older machinery, then these devices empower IoT sensors to transmit performance data. Like, again, you need sensors. So again, you have to see how many parameters, how many quantities, how many things need to be sensed, measured, observed, regulated. Okay. Then in some cases, video cameras, various types of sensors, heat sensors. Means I already told you that you may need an array of sensors or combination of sensors, sensor module, Wi-Fi modules can be also fitted and connected to provide a more robust picture. Then the age and functioning of machinery. So you may have different types of machinery. You may have electrical machines, mechanical machines, electromechanical machines, electrical circuits, electrical systems. Okay. So the age and function of machinery will determine the best solution, because day by day depreciation and deterioration of the performance also you need to see. Then an audit analysis can help determine the long-term value of retrofitting versus replacing legacy assets. So there is no problem in connecting older machinery, but you also have to see uh, long-term value and retrofitting versus replacing. So where that analysis will also help you if you want to convert or connect the older machinery to digital network. Otherwise, you have to replace the machinery. Then there is always fear of change in business model. So business model, there are drastic conditions. Every day there is new situation in corporate sector and industry sectors. Many circumstances also changes. So if business model changes, if you are adopted Industry 4.0 processes and suddenly the business model changes, so in that case, in that conditions, whether you are going to cope up. So some of the most fundamental elements of Industry 4.0 is nothing but software solutions which are built in, are having scalability and capacity for agility and resilience. They can be adaptable. But if your business or production model has to radically change, it need to meet the market demands, supply and demands, customer changing patterns, customer buying habits. Your Industry 4.0 system will give you insights. Okay, and confidence. You need to adapt and implement change quickly across. So you don't have to fear about business change, fear of change in business model. There are some of the software, some of the systems, they are adaptable, they are flexible, they are scalable, and you can easily convert or you can change your business model also as and when required. Then most important factor is retaining of staff. So if you are transitioning from 3.0 to 4.0, so we people are very rigid, we are very like reluctant, we don't want to um, think out of box. We are always reluctant to the system. We want to follow the traditional and conventional systems. So change is very hard and change is very painful also. So when companies switched to computers from typewriters, it was made resistance or reluctant at some point by workforce that fell overwhelmed by the complexity. They were thinking that typewriters are only like they are compatible. But unlike those early technological transformations, because Industry 4.0 or Industry 5.0, these are having more, they have reduced complexity. They are more user friendly. They are more, what you can say, very easy to understand kind of thing. And you can easily add them and you can easily learn them. Okay. So workflows are streamlined, manual. Means workflows are now you can streamline manual and repetitive tasks which are redundant. They are automated. Means whatever redundant work day to day, that can be automated. There are many softwares like RPA, robotic process automation, Jira, and that are office automations are there. Means office automation is different and this automation is different. So that interfaces are more intuitive. So retraining of staff is always, because we need to believe in lifelong learner. We should always update ourselves. Okay. So that is the thing. We have to change. We need to change. We need to update our skills. We need to upskill. We need to relearn the concepts. We need to get flexible with the technology. We should always be enthusiastic to learn the new things. Otherwise, we'll get discarded and will become redundant someday. So furthermore, many 4.0 technologies or processes facilitating training also, such as AR wearables, mobile optimized experiences, and today's technologies are very user friendly. So you will become very well conversant if you spend week or month. So that one need to focus on retraining of the staff also. Now another aspect, there is always fear that when the technological transformations are coming, we will lose our jobs. Even with the advent of BART, Chat GPT, AI, Bing, and other LLMs, people are thinking these jobs are going to be means technology will replace. But let me tell you, technology is not going to replace us. Okay, technology. Those who are not well versed with technology, those are illiterate in technology, they only will get replaced. If you are good at using technology, if you are very well conversant with technology, you should not have fear of losing a job. Okay, rather I will say it will add the job, but the job demand will be who are well versed, who are well learned with that technology. At least we need to learn that technology. Okay, so there is no dearth of jobs. There is not proper trained and what you can say, well versatile, well versed staff is not there, well versed employee is not there. So there is no question that fourth industrial revolution or 5.0 or Chat GPT or LLMs and other AI components or AI products will change the world. They are complementing. Every time when a new technology comes, people are saying we will lose our jobs. So, but it will avoid redundant and repetitive labor. This whatever is very tedious, time consuming, energy draining, repetitive tasks, redundant tasks, they will be replaced by the that mechanisms like Chat GPT, that robots or cobots. Certainly they are not going to replace us. Okay, and it's ideas and creative. So if you are any ideas, creative thinking, so you don't have to what we can say, worry about your job. A digitally augmented workforce is freed up to use their heads instead of to just their muscles. So days are gone, you have to use muscles for handling machines and all that big machines. So you can delegate that task to robots, cobots, and machines. In 1980, way back, there were only few thousand computer programmers in the world. If you see, there are 20 million and more than that. So there should not be like fear ki with the help of technological advancement, we are going to lose the jobs and people will remain idle. While many physical tasks will be taken by robots. Okay. And many more tasks will be created to run a digitally enhanced business. So this is complement. Then we'll come to the next. So what are the some of the challenges for implementing industry automation 2.0? So so far we have seen many benefits. Despite many benefits of industry 4.0, so far we have discussed the advantages and the good things of industry automation 4.0, but it also has some significant challenges, because if we see, we have different continents, different regions. Even India is geographically diverse country. So there are many local and global level challenges in deployment of this process, implementation of this process successfully. One of the biggest challenges for skilled workers. If you name the field, still there is acute shortage of skilled work. Let it be your local plant, let it be your local school, local college, local plant, local manufacturing sector, or anywhere. At regional level, state level, international level, there is acute shortage of skilled workers, skilled employees, skilled engineers, skilled professionals. Okay, because we are having superficial knowledge. So because there is a surge, there is a need of time that we need skilled workers who can design. If we see, most of the people, they only know fundamentals, concept, applications, and all that working. Here we need skilled workers who can design, build, maintain these complex systems. Okay. And another challenge is, for that also you need to train, upskill your employees. Then another challenge is need for robust cybersecurity measures. Cybersecurity is like a big threat for in today's world. Nothing is free on internet, nothing is secure. No system in the world is secure, everything can be hacked. So you need to preserve your data, you need to work on that. That is one of the greatest concern. With so many devices, systems, sensors and all that connected in internet, there is a huge risk for manipulation and all that. The risk of cyber attacks increases significantly, and day by day cyber security is becoming a big headache. Then businesses or corporate houses must invest in strong security protocols and regulatory update. Even training for their staff is also required regarding cyber security risk, and cyber security literacy is also required. Okay, so these are the some of the challenges. In these challenges, we are going to see there are three major aspects are there. Cost and investments are required. So you name the technology, name the solution, name the project. First of all, you need to see that it should be affordable to everybody. It should be affordable to the corporate sectors, businesses. Cost is the at the main center. Everything comes else. Then what kind of investments are required? Sources for investment. Because if you say day by day technology changes, business model changes, you cannot simply keep on investing and without getting return of investment. That is the main factor and crucial factor. Then people are reluctant to change. The resistance, there is always resistance from employees, there are resistance from other things, and cyber risks. So these are the three aspects, and these are the three major areas one need to focus while implementing industry 4.0. Then if you see challenges, so there are variety of challenges, because if you see across the globe, across international level, national level, regional level, even at local level, there are many challenges if you want to adopt the 4.0 or any process or any technology. First is economically, it is high economic cost. Then you need to adapt the business model adaptation, and within a fortnight you cannot change it. You need some time, you need some breathing time also. Then there is unclear economic benefits. Excessive investment may be required in some certain time says. You may get loss also. Then you have to see political challenges, lack of regulations. Every country, every state, every region is having their own norms, conditions, regulation acts, standards, and forms of certifications, NOCs from other bodies. That is also one kind of headache. Then there is unclear legal issues and data security. So these are the challenges which you need to think while implementing Industry 4.0. Then when we come to the organizational challenge, then IT security issues, which are greatly aggravated by the internet, need to open previously closed production shops. So that need to give more or utmost priority. Then reliability and stability needed for critical machine-to-machine communication. Okay, as M2M including short and stable latency times, because latency is very important. So for that, you need proper connectivity, proper infrastructure, network support, proper bandwidth, proper systems, proper machines, high performing machines you need. They need to maintain integrity of production process. Okay. So that is one of the thing whether one has to think. Then one need to avoid any IT snags, as those who would cause excessive production outages. Okay, this is another perspective where you have to work. Then one also need to protect industrial know-how. Okay, like content also in control files of industrial automation gear. Okay, that kind of expertise is needed. Then we are always having shortage of adequate skill sets to expedite the transition towards the fourth industrial revolution. So the let it be global or let it be local, there is always shortage of still there is unskilled staffs are there. Then low top management commitment, this is another issue, and insufficient qualification of employees. So these are the organizational challenges if one has to adopt this industry 4.0. Then social challenges are there. So privacy concerns as far as personal data and organizational data need to be intact. So that is again there. Cyber security threats are there nowadays. There is mushrooming of cyber security attacks, and hackers and other data stealing is very crucial. People are finding like attractive ways to steal your data and to get you trapped. Then you need proper surveillance and distrust. Then general reluctance to change by stakeholders. So there are many stakeholders in the organization. They are reluctant. They are rigid to make a changes. No one wants to go for modernizations. Very few people they are backing or they are in the favor of modernization or going for new processes. And due to there are fair possibility of losing many jobs as if you use RPA and other softwares. So many redundant and repetitive tasks will be replaced. So IT control processes. So especially it is difficult for blue collar workers. Then increased risk of gender inequalities in professions with job roles are there. So if you are using AI systems, so that is also one kind of thing we need to work on that. So these are the very important challenges. So we cannot say we have seen goody things and right side of the 4.0, but at the same time we also need to see what are the consequences, then unemployment and other issues, social issues. Then another type of challenges are the need for considered investment in automation and ICT. So this is another challenge because day by day ICT components and the hardware prices and software prices are rising. So you also have to wisely plan how much investment you can do in that. You may need sensors, you may need signal conditioning devices, you may need modern controllers, modern computing devices, then actuators, smart systems, intelligent systems, transmitters, transceivers. So these are some of the things that you have to see. Then the adoption of new collaborative business models, including new possible partners such as telecoms and internet service providers. So again, you have to rely on these telecom companies as well as ISP providers, hardware vendors. So that is another crucial part. Then the ownership, confidentiality, and security of the large amount of collected data needs to be cleared. It need to be assured. It need to be ensure the trust and data protection, because data protection is a headache nowadays. Then there are some of the several legal issues such as employee supervision, employee attendance, employee behaviors, product liability, intellectual property, and that must be tackled. We simply cannot rely on machines and systems. Now let us come to the barriers for Industry 4.0 implementation and deployment. It is taken from McKinsey. So there are 5 barriers mentioned by manufacturing with no limited progress. So first is difficulty in coordinating actions. So you need to interface with different organizational units. So coordination is one headache with different like raw material handling, office and production, quality control, marketing, and all that. Then there is lack of courage to push through radical transformation. Okay. Then lack of necessity talent like data scientists and skilled data scientists with that kind of expertise is one of the thing. Then means you need skilled workers, skilled expertise in data science, AI, and machine learning experts. There is acute shortage. Then concerns about cyber security. You say when working with third-party providers, that trust is needed. Then lack of clear business cases that justifies investments in the underlying IT architecture. So these are the some of the 5 barriers. And additional top barriers mentioned are like concern about data ownership when working with third-party orders. Then there is always uncertainty or Murphy's law about outsourcings and lack of knowledge of providers. Then challenges with integrating data. So data integration is another thing which is very crucial from disparate sources in order to enable the Industry 4.0 applications. So these are some of the barriers. Now, let us move to the so far we have discussed introduction. So we have discussed benefits, opportunities, challenges, and all that. Let us move to the applications of Industry Automation 4.0. So there are 3. We can say basically we can categorize in 3 types. manufacturing and assembly. This is first part. Second is logistic and supply chain management. Third is healthcare and medical devices. Actually, there are many. So when we say real world applications, day-to-day applications, Industry 4.0 is already being implemented in a variety of industries. And nowadays, many business houses, corporate sectors, industries, manufacturing units adopted it. Some of the examples are healthcare. In automotive industry, for example, smart factories are using IoT sensors and AI algorithms to optimize production lines and reduce downtime. Then, in the healthcare industry, also it is used, and they are using to improve patient outcome by enabling remote patient monitoring, like telemedicine is there, telehealth units are there, personalized treatment plans are there, predictive maintenance of medical equipment is there. Then these applications are also using Industry 4.0, are just beginning, and businesses continue to explore new ways to leverage technologies to gain a competitive edge. So as such, there are very many applications. We will summarize few here. So future, if you see future of industry automation 4.0, it is nothing but integration of AI and machine learning. So nowadays, not only to industry automation 4.0, AI and machine learning is used everywhere. Okay. Then expansion into new industries and potential for fully autonomous factories without manual intervention. Now, when we want to elaborate the future, so it is continuously evolving, and slowly we are going to migrate to 5.0. We can expect over more advanced and more sophisticated technologies and applications emerging. So if you want to name the particular interest, use of augmented reality, virtual reality, workplace, then we can also overlay the digital information onto physical world, AR, VR, and relationship. Another area of focus is of the development of autonomous systems that can operate without human intervention. Means totally fully functional autonomous factories. Then from self-driving cars, unmanned aerial vehicles, and slowly and gradually we'll go to the transform industries that will create more opportunities of innovation and growth, will be fully autonomous. So, so far we have discussed about Industry 4.0, and already people started working on Industry 5.0. So I would like to uh, explore it further or elaborate it further with the Industry 5.0. So there are many definitions of Industry 5.0. If you refer different literatures, different research papers, different magazines, different books, more or less definition is same, but the way they put, there are more or 80% definitions or 80% part is same. It it is there. So let us walk through this. Industry 5.0 is a model of the next level of industrialization. So that is naturally, as we are Industry 5.0, so it will have upper hand by the return of manpower to factories. So here manpower, human power or human touch is given more importance. That was not given to that much importance in previous industrial revolutions. It is again distributed production, intelligent supply chains, and hyper customization or more personalization, all aim to deliver a tailored customer experience time after time. So this is the definition which is coined by the Frost and Sullivan. These are the people who are contributing a lot. So they have said it is the next level of industrialization, and the main at the center stage is human being. Okay. Then another thing is that Industry 5.0, many people wanted to bring human, social, and environmental dimensions. If you see, day by day, we are losing our natural resources, and pollution is there, and many more things are there that is disturbing our ecosystem. So many people wanted to bring back human and social environmental dimensions back into equations. So they were felt that that was not available in Industry 4.0, and initially mainly focus on the human touch. Wait for a while. Huh? Okay. So Industry 5.0 recognizes the power of industry to achieve societal goals. Means here, human value system, society, means all the technologies, all the technological advancement, innovations, the discoveries they should lead to the progress of the last person of the society. That is the motive. So let it be any field, any domain, any technology. And human life should get improved. Okay, so this is the essence. So that's the reason industry 5.0 is slowly molding, slowly grooming, slowly shaping. And what is there? They are trying to bring human touch. Industry 5.0 recognizes the power of industry or whatever technological advancement there. Societal goals beyond jobs and growth to become a resilient provider of prosperity. And how they are going to achieve it? By making production respect the boundaries of our planet. We should preserve our mother nature, planet earth, and placing the well-being of the industry worker at the center of the production process. Okay, forget about technological advancements. Tomorrow industry 6.0 will come, but slowly and gradually we are losing human values. We are harming our environment. We are harming our mother nature planet. And that's the reason. So people want, or whosoever are policy makers, thinkers, think tank is there, they are believing that 5.0 may we must concentrate on human touch or a complete ecosystem. So let us walk through some of the definitions. So definition one is there. Industry 5.0 is the first industrial revolution led by the human based on 6 R's. So they are concentrating 6 R's: recognize, reconsider, realize, reduce, reuse, and recycle. So this is nothing but industrial upcycling. Okay. So this is the new term coined by, and human being and natural resources, they are kept on the center. The systematic waste prevention, it is nothing but a systematic waste prevention technique and logistic efficiency designed to evaluate life standard, innovative creations, and produce high quality custom products. And this definition was coined by Michael Rada, who is founder and leader of Industry 5.0. Okay, so these 6 R's are very important. Then there is another definition which is given by Nahawandi, yes, and it was from the journal Human Centric Solution Sustainability. They have contributed one paper on that, and they are saying that Industry 5.0 brings back human workforce to the factory, where human and machines will be interacting, and they are paired to increase the process efficiency, in which by utilizing the human brain power and creativity through the integration of workflows with intelligent systems. I already told about intelligent systems. Means here you don't need to waste your time, energy. That what are complex things, what are the tedious, cumbersome, repetitive, redundant, that can be completed, that can be assigned, that can be delegated to robots or cobots. Collaborative robots are coming. Okay, so this is another aspect. Now there is another definition that is by European Economic and Social Committee, states that it is the new revolutionary way. It is the new idea. It is the new process which is named as Industry 5.0. It integrates, it augments the swerving strengths of cyber physical production systems, as well as it is also clubbing human intelligence to create the synergetic factories. Okay. Furthermore, to address the manpower weakening by Industry 4.0, so what your lacunas, what are the problems associated with Industry 4.0, the policymakers are now looking for innovative, ethical, and human-centered design. Okay, it is nothing. It is here technology upgradation is there. In earlier you have smart systems. Here intelligent system. Here smart machines earlier. Now you have intelligent machines. Smart agents. Smart sensors. Now you have intelligent agents. But here also ethical, human-centered design is there. And here main aspect is to bring back human manpower to the factories. It is combination of machines and man, or interaction and interfacing between human and machine. Another definition, it is nothing but it is the age of the social smart factory where cobots communicate with humans. Cobots are collaborative robots. Okay, so these are non-programmable robots, but they can sense, they can do some actions, and they will help human being in a complicated and complex task. So social smart factory uses enterprise social networks for enabling seamless communication between human and CPPS components. This is another definition, another dimension. Then Hadman and Henry suggest that Industry 5.0 compels the various industry practitioners, okay, then information technologists and philosophers. Here, three different people will be there to focus on the consideration of human factors with the technologies in the industrial systems. So this is another aspect of Industry 5.0, sorry. Then we have another definition with us. Industry 5.0 is nothing but a symmetrical innovation and the next generation global governance, which is incremental advancement of Industry 4.0. Okay, wherein Industry 4.0 is asymmetrical innovation, and it also believes in design orthogonal safe exits by segregating hyper-connected automation systems for manufacturing and production. And last definition is Industry 5.0 is a human-centric design solution, okay, where human being is at the center, where the ideal human companions and cobots, they will collaborate with each other, they will communicate with each other, they will take decisions, which task will be assigned by cobots and which task will be completed by the human being. It will also enable the personalizable autonomous manufacturing through the enterprise social network. This in turn enables humans and machine to work hand in hand. Okay. Also, cobots are nothing but they are not programmable machines, but they can sense, they can understand the human presence. So in this context, the cobots will be used for repetitive, redundant, complex systems, complex, tedious, cumbersome, energy-draining tasks, which are labor-intensive work, whereas or wherein human will take care of customization and critical thinking. That is nothing but thinking out of. So this is one of the best definition I can say. So where you machines and human being are believed to work hand in hand, and they will finish the task before the deadlines. So when we say these all are the definitions, let us take overview. So global industry 5.0 market overview is given here. So there are many key players in the market: Rockwell Automation, ABB, IBM, Microsoft. And if you see growth drivers are, there is rising emergence of industrial automation, IIoT, and AI technologies. There is upsurge or demand or rise in technological advancement in industrial robotics. Cobots are coming. Then if you see continent-wise, global market analysis is given. Asia Pacific region displays significant opportunities. We are from Asia Pacific region. So 2022 to 30. Then owing to growing adoption of industrial automations. Then if you see, these are the market analysis. So marketing, supply chain, automotive, healthcare, electrical, others, these are shown here. This is global market analysis. So this picture is very, what we can say, encouraging, and it is very optimistic also. So let us discuss Industry 5.0 features. So if you see resilience, nature, sustainability, and human-centric, these are the three main pillars of Industry 5.0. So Industry 5.0 is a new manufacturing concept. I can say intelligent concept where human being has given utmost priority. It emphasizes the interaction of humans and machine, communication or interfacing of machines and human being is believed, it is expected, highly expected. They will work hand in hand. They will work like a co-worker, ideal co-workers, and they will finish the task. Whatever difficult, time-consuming, tedious, complex tasks will be done by machines, and critical thinking, innovation, controlling, customization will be done by human being. And next, this is the next phase after Industry 5.0. It entails the cooperation and courtesy between increasingly powerful and precise machinery. The human being's unique creative potential will be used here. So we can see there is no fear of jobs. You need to handle cobots. Okay. Then another pictorial or pictorial representation or diagrammatic representation one can see here. It is human-centric. Human-centric approach promotes talents, diversity, and empowerment. Sustainability leads action on sustainability and respects planetary boundaries. We should not harm our mother nature, or we need to preserve our ecosystem overall. And it is also resilient nature. It is agile and resilient with flexible and adaptable technologies. So these are the best features of Industry 5.0 Sen. Then there are three essential facts about Industry 5.0. Industry 5.0 is aimed at supporting, not suspending humans. Okay, so there should not be any fear of losing jobs or unemployment. Industry 5.0 is about finding an optimal balance between efficiency and productivity. And third main aspect is what? The progress of Industry 5.0 is unavoidable. Okay. And maybe in coming days, we can expect Industry 6.0 also. Then let us go through the concept of Industry 5.0 again. It has human-centric solutions and human-machine interaction technologies that is interconnecting and interfacing and combining the strengths of human machines. See, if you see SWOT analysis, so we have strengths, weaknesses, opportunities, and threats. What we are supposed to see, what are your weaknesses you need to convert into strengths. So if you see Industry 4.0 and other revolutions, they have their own advantages, disadvantages. So what people did here, what policymakers did here, they have combined, augmented, and clubbed the strengths of humans as well as machines. Okay. And that is coming up with a new vertical that is nothing but the Industry 5.0 that gave birth to Industry 5.0. Bio-inspired technologies. If you see all our algorithm systems, many actions are taken from Mother Nature. If you see all our systems, they are taken from bio-inspired. Okay. So there are bio-inspired technologies, bio-inspired algorithms, bio-inspired programming techniques. They are used, and smart materials, or rather I will say intelligent materials, that allows materials with embedded sensors and enhanced features while being recyclable. It also believes in real-time based digital twins. Digital twins is the virtual simulation of exactly what is going on to model the entire system. Then cyber safe data transmission, storage, analysis of technologies that are able to handle the data and system interoperability. Means systems, if business model change, technologies are changing, it will easily adaptable. Then introduction of AI to detect casualties in complex dynamic systems, leading to actionable intelligence. Okay. Then Industry 5.0 also believes in the technologies for energy efficiency, reliability, trustworthiness, autonomy, such as technologies mentioned earlier, and that will require large amounts of energy. So this is the overall concept. Okay, but at the topmost, human-centric is the having top priority. This is another diagrammatic representation. So if you see, Industry 5.0 is a solution provider for people and for our planet. Earlier, only technology was concentrated, so it will reduce the cost due to resources efficiency. It will empower workers remaining in control. Then competitive innovation may you can cope up, attracting best talent. It has adapted training for evolving skills. Also, it believes in competitive edge in new markets, and it has improved safety and well-being. Okay. So Industry 5.0 is for people also and our planet also. It is not only for factories, profits, making businesses and all that. Then, if you see, these are some of the segments of Industry 5.0. Disaster recovery management plan. So you can very well plan. You can have AI predictive machines for disaster estimation, forecasting, and planning and recovering. So in conventional systems, you can introduce AI and other sophisticated systems with sensors and arrays and all that. Then smart education is another aspect. You can introduce hybrid and all that. You can bring uh, technology in communication. You can have hybrid, modern, traditional approaches in education, automation of many redundant practices, redundant things. Then supply chain management is another domain where you can introduce this Industry 5.0 efficiently, as well as smart hospital. Okay. Rather, I will say intelligent hospitals means robots or cobots can help doctors, physicians, surgeons in critical operations, critical procedures. Then cloud environment can be used for storage, safe data handling, and integration of data, integration analysis of data where you can place it. Then production management can be channelized and can be efficiently done with the use of Industry 5.0. So these are some of the areas where Industry 5.0 is having a demand. Now let us come to the key enabling technologies of Industry 5.0. So you can see big data analysis. Big data analysis will provide you customization, faster and better decision making, real-time forecasting. Then Internet of Everything's or IIoT, Internet of Industrial Things, that will help you asset productivity. It will help you in cost reduction. It will also help you in supply chain and logistics, and it will also reflect intelligence in work. Then you have blockchain. Blockchain is another technology. It is a very safe, secure technology. It is decentralized management. It is having transparency. It create digital identities, and it is having computationalization approach, and it is very secure. One of the most secure technology. Then you have digital twins. This is virtual platform where you can see the entire system. You can see the simulation. It will reduce your cost. It will be predicting future errors. Okay, so that you can take appropriate actions and mitigate it. It will suggest. It will give you design customization, predictive maintenance also. Then if you use 6G and beyond, you can get smart resource management, low latency, ultra high reliability, good connectivity. Then cobots are the collaborative robots. They will also help in increase productivity, because here you are using the strengths of human being as well as robots. Okay, that will be clubbed together, and that will give you another kind of better outcomes. It has robustness in nature, uh, enhanced dexterity. Then it is more consistent and accurate. Then, with the introduction of AI, you will lead to intelligent automation, greater efficiency, quality control, quick decision-making capabilities like human being. And at last, edge computing will provide you lower latency, faster communication, faster interface, increased cyber security, or with less threats, expanded interoperability, and reduced storage costs. So these are some of the technologies which can be used for in Industry 5.0. Then you have another kind of things where you can use Industry 5.0. You can see security surveillance, solar energy for managing smart ambulance, traffic priority, traffic management, smart transportations, smart agriculture, smart farms. Then you can have environmental sensors. This is a complete picture. You can see. Then you have RFID technology for tagging and all that. Air cleaners for air pollution that can be managed. Utility management services. So you name the field and service sectors, everywhere you can use this technology. Clean energy, smart grids for energy management and all that. Water quality and water management, smart offices, smart parking, smart health, smart hospitals. So these are the some of the things where you can use this Industry 5.0, and these are the sectors where 5.0 will have more dominance. Now let us come to the some of the applications. So like intelligence healthcare, you can use supply chain management. Then you can use in manufacturing and production lines. Everywhere efficiency will be increased, cost will be saved. Then you can use in smart communication. It will improve visualization and creativity. There will be no passive classes, more interactive and more active e-learning experiences will be there. Real-time blended teaching and learning, no boring classes, no boring monotonous teaching. Then in disaster management, it has ability to handle consequences in disaster. So whenever natural calamities will be there, like earthquake, tsunami, and anything other, so it will be used in research and rescue operation. Then it can be used in enhance the level of preparedness. Then cloud manufacturing and supply chain management. So these are the some of the areas where Industry 5.0 applications are there. Then the cloud manufacturing ecosystem, if you say it can be used in manufacturing plant, IP management, and then you can have monitoring and scheduling. Then manufacturing plant in India and overseas. So everything can be managed using cloud manufacturing ecosystem. So if you see there are bilateral communications through cloud, and from center you are connected to For logistics also, you have connection and control over both the plants, as well as you can easily manage the IP. Then, when coming to the um, future research opportunity and limitations, see, every technology is having its limitation, its opportunities, its advantages, its disadvantages, its pros and cons, and also it has some scope. There is always scope for improvement. The in very near future, we will get acquainted with industry 6.0 or industry 7.0 also. So when we say opportunities, smart infrastructure, clean energy, intelligent transportation, smart clothing, binaural bits, these are the some of the opportunities, big opportunities and good opportunities, we can say. Then limitations, uh, no one is secure, no data is secure on the planet. So no machine on the planet is secure. So we have to think over the security aspects also. There is acute shortage of highly skilled workers or professionals. Human machine collaboration is again another issue. Okay, whether it will work or not, that is another question. Adjustability and adaptability is also one more thing, and digital forensics in case of uh, security is another area where we have to work a lot. Then future research. So if you see, blockchain is the area where a lot much opportunities for blockchain is there. Then hyper intelligent networking, quantum computing, and ultimate security and trust. These are the four areas where ample opportunities are there. So this complete diagram explains about opportunities, limitations, and future research of our industry automation 4.0. Then if you see industry 4.0, there you can see utilization wise. So we have industry 5.0 applications, and at one side we have technologies like edge computing, digital twins. So if you take one example, intelligent healthcare, where edge computing is having high utilization, wherein cobots are having low utilization, as well as swarm networking is having low utilization, and digital twins and private mobile network is having medium utilization. And in education, if you take, cobots are having low utilization, as well as swarm networking is having low utilization, wherein edge computing is having high, extended reality is having high. So this way, at one side we have industry 5.0 applications, their utilization, and other side we have enabling technology. So if you compare, so if you want to use the technologies for that, so you have to wisely select these technologies, the enabling technologies and the domain. So here we have 5 domains, 5 to 6 domains are there: intelligent healthcare, cloud manufacturing, supply chain management, manufacturing and production, education, human cyber physical system, disaster. At other side we have various types of technologies like edge computing, digital twins, cobots, internet of everything, artificial intelligence, big data, blockchain, 6G and beyond, swarm networking. Swarm is bio-inspired. Then network slicing, extended reality, and private mobile networks. So private mobile network, if you see, it has got higher utilization in manufacturing and production, as well as human cyber physical systems. Okay, coming to the next slide, there are some of the potentials, challenges, and future direction. We have already discussed one slide about opportunities, future. Same is there. If you see drug development and pharmacy industry, it has great future. Smart factory or intelligent factory is another area. Green ecology, green should be given utmost priority to preserve mother nature. Then smart fashion, smart clothing, and smart textiles is another area. Then intelligent traffic, innovation ecosystem, and fusion energy and COVID therapy. So these are the some of the areas where we find potentials. Then challenges, again, we have already discussed. Human. There is issue with human co-workers. Then how we can work with human robot co-working, again there will be some issues. Then scalability, how largely scalable it is if you want to scale at larger levels or miniature levels. Then data security is another issue. Skilled workforce or skilled manpower is another issue. Policies and regulatory compliance and privacy preserving transactions. Future directions, again we have discussed blockchain, quantum computing, global industry standards and industry standards, ISO standards, cognitive edge, continuous training, human machine co-working politics, So these are the future research areas. Then there is one example how will cobots are working with. So here you can say human can assign their task to cobots. So a cobot looks at a human operator is doing and then decides if it should assess the human based on the surrounding environment. You can see stepwise 1, 2, 3, 4. So you can see this is human intention analysis. This is cobot decision. Shall I help the task? And here you can see raw data. It is raw data handling is done, audio analysis and everything, and that is given to this controller, and then human intention analysis. So this is combined. So this is one of the picture how robots and human being can work together for better results. Then we have another thing, industry 5.0 challenges, future directions, and these are the applications. So here these are the domains like digital drug, fusion energy, smart fashion, and these are some of the challenges: data security, skilled work, and this also future directions, blockchain. So where you can use this. So one is challenges, one is future directions. So this is tabular format. Earlier formats were pictorial or graphical things. So this will be also, we have to think about challenges, future directions, and domains. So some of the technologies are applicable everywhere. Smart factory, there are many things in innovation ecosystem. AM scaling is not there, or you cannot use fusion energy and all that. Okay. Then we will come to the highlight of Industry 5.0 as compared to Industry 4.0. Industry 4.0, sorry, Industry 4.0, it is focusing on connecting machines. It is focusing on delivering customer experience. It is more on customer or personalized aspect. It is focusing on mass customization. Here, hyper customization will be there. It is intelligent supply chain. It is responsive and distributed supply chain. Industry 5.0. Naturally, Industry 5.0 is having upper hand. Here we have smart products. Here you will be having experience activated or interactive or intelligent products. Here manpower distant from factories. Here return of manpower to factories. So this is a very good slide to explain what are the similarities and discrimination between or dissimilarities between Industry 5.0. So what we say to the end, the human touch revolution is now underway. So if you say Industry 5.0 is coming up, so role of robots or role of cobots will be there. There will be mass production and that too also mass personalization. Then return of human touch will be there. Then cobots will come and it will have broader implications. It will be naturally superior and will be more fruitful and productive than Industry 4.0. Then how to thrive in the next industrial revolution. So one has to need, whether it is individual, whether it is organization, whether it is as a system, we have to understand and utilize the automation and robotics and how they are used to enhance the production process. We have to understand machine learning techniques and models and how to apply them. We have to be lifelong learner, invest in data and AI technology. Then we have to reimagine job descriptions, what types of job roles will be there, profiles will be there. Okay, and we have to hire new talent with relevant skill sets. Okay, then strategically leverage human capital resources. Then coming to the end, Industry 5.0 is nothing but it is the next industrial revolution, which is people-centric, human-centric. It is about clubbing, augmenting, and uh, getting together the digital transformation of business with integration of human capital with technology. And you have to use cobots and man. The fifth industrial revolution is not just a matter of technology. It is about harnessing of the power of people, clubbing the strengths of people and machine together to create new opportunities and unlock value and drive growth. So there are few concerns about Industry 5.0. Here, humans are expected to add high value tasks in manufacturing and policies. Then we need to focus or think about standardization and legalization will help to preventing serious issues between technology, society, and business. Particularly, senior members of society and stakeholders will find it is much more difficult to adapt with the new industrial revolution. It will be very fast, rapid, and highly efficient manufacturing, and that may result in overproduction phenomena. That is another headache. Implementation of transformation should be also taken into consideration. Also, we should not forget about how our autonomous system can incorporate ethical principles. Okay, there is a huge debate on now AI standards, AI ethics, and all that. Then there should be explainable ethical behavior solutions in autonomous systems. And ethical behavior in autonomous system must be subject to verification and validation. And there is New Zealand and Australia and other few people, few researchers, they have come up with 5C journey or 5.0. That is nothing but coexistence. So machines are simple tools for humans or they work independently. So that was the first and second industrial revolution. In third industrial revolution, cooperation was there. Machines and humans share partially overlapping workspace. They sometimes temporarily share tasks but do not work simultaneously on the same task. So that is the difference between first industrial revolutions and third. Then in fourth industrial revolution, collaborative approach was there. Machines and humans accomplish tasks via synchronized interactive joint activities. And if you see in Industry 5.0, compassion is there. Machines, with the help of cobots, sense human emotions, needs, and preferences. Human care about the health of empathic machines. So there is joint collaboration of robots and human being. Also, Industry 5.0 is one more good thing or best part. Co-evolution, machines and humans grow in capabilities through human-machine interaction. So this is 5C journey. With this, we are also concluding our journey of Industry 4.0. And from my side, I am open for questions.
Dear participant, if you are having any question, hello.
So thank you, sir. Very nice presentation, and the way that you prepare the slides is very nice. And very patiently we explained Industry 4.0, 4.5.0. Thank you so much, sir.
Welcome, man. I'm not an expert in this field. I just know ABC of
You
this.
gave the better idea on 4.1 and 5.0. So usually which one is correct, sir? 4.0 or 4.0?
Uh, Actually, pronunciation is 4.0, but we got habit to 1.0, 1. So that actual pronunciation is O. But we are habitual to numericals more, na 1.0, 1 version.
Yes, yes.
So many times I also speak 5.0.
Really useful, sir.
Thank you, ma'am. Thank you so much. I tried my best.
Sir, can you share the recording, sir, for this?
You can ask the organizers, ma'am.
Organizers.
I will share slides.
Okay, thank you so much, sir.
I
Really,
will,
that would help us a
I will
lot.
share my email ID. So in case anyone requires.
Okay, can you share in chat box?
Yeah, yeah.
Any question from participant? Okay, fine. Thank you so much, sir, for excellent presentation and wonderful explanation. Actually, such a best insight of industrial automation 4.0 and even 5.0. And you have explained at the end of session what is the evolution from 1 point, not 0, 1.0 to 5.0. So thank you so much, sir, once again. Thanks a lot.
Welcome, ma'am.
Now, dear participant, will start our next session at 3 o'clock. So we'll have a break of 10 minutes. Thank
Ma'am,
you.
thank you, ma'am. Shall I close my meeting?
Yes, sir. Thank you so much.
Thank you.
Okay,
Thank you,
thank
everyone.
you.
Hello, participant, please make your video on. Let's have a group photo. Participants, please make your video on. Once more, sir. Have you taken all?
कॅमेरा चालू कर. माईक चालू केला का? दादा बोला. Thank you all the participants.
Thank you all.